Hey Thinksters, what's up? It's Chris, founder of Thinkster.com, and welcome to this video. Thank you for taking your time to watch this video today and learn and improve your Python by a small margin today. So today we are going to address the list reverse method. Basically, we want to answer the question what is the most Pythonic way of reversing a list in Python. And now this seems trivial. So I've already started writing the methods here. I've prepared this and I will just go quickly over the code. So to save you time, I won't write the code like as I usually do, like online. I will just use prepared code. Okay, so say we have a list of names, for example, a list of strings like Alice, Bob, Carl, and Dora. Now we want to reverse the order of the elements in place. And if this is your goal, you just want to reverse this list in place. So this list object names in memory, you want to replace it and reverse it and replace the result with the reversed elements. Then you would simply use the list method dot reverse. Okay, so on the list names you call the method reverse. So usually if you like in object orientation, if you call a method on an object, then usually this method will modify or manipulate the values stored in this object. Okay, so it will only be visible for this object, and this is exactly what we want. Yeah, so we want to, like, we have a list object, we want to modify this object in place, so we want to reverse the order of the elements, so we call the reverse method on the object. Okay, so this is like the object oriented standard way of doing it, to reverse the order of the elements in place. But what if you want to like create a new list, and because say you have some elements you want to leave the original list untouched. So basically you want to create a new list with the reversed elements, but this should be a copy of the original list. In this case you would use slicing. Okay, and this operation slicing, it's even more concise than the previous notation. You could also like store the result in a new variable called, for example, names2, and this would be no problem. Okay, so then your original list names would be unmodified, so it would be unchanged. And how does it work, slicing? Okay, so with slicing you have 3 parameters. Okay, so in this square bracket notation you can so basically a slicing helps you to carve out a substring or subsequence of your original sequence, and you would define which sequence to carve out with the start, stop, and step parameters. Okay, the start parameter just tells us the index on which we start our slice. Then we have the stop index. It shows us the index where we want to stop our slice, and then we have a step size. So for example, we can carve out every element, we can carve out every second element, and so on. Okay, and by defining these 3 parameters you define the sequence that you carve out from the original sequence, and you can use the default arguments by just leaving the space where you should, so the place before and after the colon empty. Okay, so this means we have the default start index, default stop index, which means that you slice from the left to the right or from the right to the left using the default argument. So you slice over the whole sequence. But then we use as a step size -1. So the default step size is 1. If you would leave it empty, then you would just get a copy. But if you define it like -1, this means that instead of carving from left to right, adding like 1 step at a time, we simply carve from right to the left. Okay, so we carve in the other into the other direction, from the last element to the first element, and this then creates a new list, and we assign a new list to this variable called names2, or let's leave it originally names. So we override our original list names with a new list. Okay, so this is not the application scenario where you would usually use slicing. You would use slicing to copy the list and return a new list with new elements, so that you don't modify the original list. But in this case we would just live with it. Okay, and you see all of those methods produce the same output. Okay, so we have Dora, Carl, Bob, and Alice, and this is the reversed from Alice, Bob, Carl, and Dora. Okay, so the reversed order. So all of those methods produce the same output. Okay, but then there's a third way, and this is the reversed built-in function. So don't confuse it with the list.reverse method, because the list.reverse method is a method. Okay, so a method always operates on an object. Okay, so you don't call this a function, you call it a method, because methods change objects usually. So it operates on an object. But if you want to, you can also use the function reversed. This is not called on any object, as you see. It's Python built in, so it ships with the standard Python library. You don't have to import anything for this. You can just call reversed, and then you pass any iterable here, and the return value is an iterable by itself. So you pass an iterable like a list. An iterable is an object over which you can iterate, and it returns an iterable. And an iterable is a more concise way of iterating over some sequences. Okay, so for example, you can call reversed 1, 2, 3, and this creates an iterator object. Okay, this is an iterator object, a list reverse iterator object. And now what you can do is for I in reversed 1, 2, 3 print I. Yeah, so now it goes over the elements in reversed order, and you don't even have to create a list here. Of course, if you want to have a list, then you can also do the following. You can use the list constructor, and you call reversed 1, 2, 3. Then you would create a list object. So the list constructor also takes an iterator, which can be the reversed iterator if you want, and it converts it to a list of values. Okay, so the iterator is usually best if you want to iterate over a sequence of values without needing to create a list object in memory, because a list object is more powerful but also more expensive in memory in terms of memory overhead. So usually you don't. The advantage of an iterator is that you don't have to instantiate all objects in advance. Yeah, you can instantiate the object as you go over them. Okay, so the iterator just has to implement the next method that gives you the next element and the next element and the next element until there's no element left. So now the iterator could decide to dynamically create this next element. Okay, each time you call it, you could create the next element, and so therefore you don't have to. In an iterator, you don't have to define all the elements in advance and store them in advance in your memory. So it's a bit more memory efficient way of handling it. And therefore, in this case, if you just want to iterate over it and you actually don't need a list, then this method, the reverse method, may be your preferred method. Okay, so and then just for comprehensibility, I added a basic loop method that would be used by coders coming from Python, from Java or C++ or so. They would just maybe create an empty list and define loop variable I, index variable I, that goes from the length of the names -1. So this is the last element of your variable, of your list variable names, the last index. This one refers to the last index. And then we have -1, which refers to the so because this is start. I mean, in the range function, the first argument is the start argument. The second one is the stop argument. It's like slicing. Okay, so we have the start argument, the stop argument, and the step size argument. You see, the step size is -1. So we go from the last element to the first one. And what is the index of the first element? It's 0. But the stop, this you have to know, the stop argument is always excluded in any definition. It's also in slicing. The stop argument is never included in the final slice, and all this is also true for the range function. So therefore, we want to go from the right to the left until we reach index 0, but 0 should be included. So therefore, we simply like add 1 minus 1 to the 0. So we have -1, which we overshoot. So we overshoot on purpose so that we can include the last index 0. And then we go simply -1. We use step size -1. We start from the top right from the right element and go -1 to the left until we reach the element with index 0. And then simply we append each element, using our index. Each element from the original list names, using simple indexing here. And finally, we print the last list, and the return value is also the same list with the elements in reversed order. Okay, so we start with Alice, Bob, Carl, Dora, and now we obtain the list Dora, Carl, Bob, Alice. And then there's also a variant, which I find even more Pythonic. If you want to use loops to solve this problem, then you should maybe use negative indexing. Negative indexing is similar to positive indexing, just that you start that you index the element. So maybe I can show you a graphic here. Yeah, so you have the elements Alice, Bob, Carl, and Dora, and Alice has index 0. This is positive indexing. 0, 1, 2, 3. Okay, Dora has index 3, and negative indexing is just the inverse. So you start -1. You can use -1 really in your as an index. -1 would refer to the last element, Dora, and -2 would refer to the second last, Carl, -3 to the third last, Bob, and -4 to the fourth last, Alice. Okay, so you can use this negative indexing scheme to access elements in your original list. And here we like I takes on the values 1, 2, 3, 4, and so we use -1, -2, -3, -4 to access the elements in reversed order. So this is also possible, but it's these last two methods are quite complicated, so I wouldn't recommend you using them. And then I also have implemented performance evaluation. So let's quickly go over the performance evaluation. So I used I defined 5 functions, reverse 1 to reverse 5, and in each function we simply create a simple list and reverse it using the method we have just discussed. And we have different methods to reverse the list, so we should expect that they have more or less the same performance. So let's check. Yeah, we use the timeIt function. We pass the reverse method and also the number of times we want to execute the reverse function, and also the number of times to execute this function. And we would expect, yeah, that more or less they all methods have the same runtime, but this is far from true. So the true runtime, you see, the list reverse method has actually it only takes 0.002, I guess it's milliseconds, and slicing is equally efficient, and the reversed function is equally efficient. Okay, so they are more or less the same, these 3 methods, but the loop methods, they are much inferior to our used methods like list reverse, slicing, and so on. Okay, so these methods, the loop methods, are not only are they confusing and hard to understand, hard to read with this indexing scheme, and so it's really difficult to follow, and it also takes more space. It also is less time efficient. Okay, so you should not use those methods, and the reason is that, of course, I mean, here you implement everything yourself in Python, but if you use functions like slicing or built-in functions like slicing or the reversed built-in function or the reverse method, these functionalities are actually implemented in CPython. So Python is implemented in CPython, which has a C++ backend. So it can be quite performant. C++ is much more performant than Python. So if you use this pre-implemented functionality, then of course you can access the these powerful methods. But if you do it yourself here, then you see you are like 3 times less efficient. I mean, even those methods, append and so on, they also use CPython, but I mean, this iterating over all values here, this would be done usually in C++, so therefore this would be even more efficient. Okay, but because here you are doing it in Python, so here we simply transform each and every command into a Python equivalent, and then it executes the Python commands. And then of course, I mean, the mini Python commands, so maybe you have like 10 Python operations which you need to operate here, for example, and here you have only 1 Python operation, and this 1 Python operation is already implemented efficiently. So of course this, like, overall it is faster than breaking it into 10 Python operations. And then even if each of these 10 operations is implemented efficiently, you still have this constant overhead of executing many Python operations again and again. Okay, so it's much better to use built-in functionality to stand on the shoulders of giants. If you want to learn more about Python, if you want to become a Python master, then check out our Coffee Break Python workbook. It has 127 puzzles. Here, 127 Python puzzles. For example, here you see we have many different puzzles like swapping variables and so on. So this workbook is really great to bring you up to speed and improve your increasing your understanding of Python code patterns. Okay, so because we address many different small and big code patterns which you will see again and again in your code. And if you just understand these patterns, if you burn them into your brain, then you will start seeing source code, seeing the meaning of source code much quicker. So check out the book, Coffee Break Python Workbook. We have a link in the description below. You can also Google it. And yeah, thanks for watching this video. See you in the next one. Bye.